So we have a data set here, which is the time to make a sandwich in minutes. So this is like if you're at a sub restaurant or you're trying to fill some order somewhere, and people come up to you and they ask you to put their food together, and someone is clocking you, because that's important, to see how long it takes you to fill that order. So here we go. Some orders take 6 minutes, the next one took 6, the next one took 7, etc. We're going to use this data set to get a mean value and a standard deviation the intuitive way. It is also the cumbersome way, but it's the easiest one to understand why it works. So we're going to do that one first. The first thing I'm going to need is the number of data points. So I have 5 columns and 4 rows. That should be a total of 20 data points. So I'm going to jot that down there. N is 20. Lovely. The next thing I'm going to do is I'm going to look at what types of numbers are in my set, because you could go 6 plus 6 plus 7 plus 5, etc. in order to get the average, but if you miss even one number, you're going to have to redo the whole thing, and nobody likes that. So we're going to start off here. The lowest data point I've got is a 2, so I can have a 2 in my set, or a 3, 4, 5, 6, 7, or an 8. So I'm going to go through this data set, and I'm going to start hunting for how many of these show up there. So let's do this. I got a 6, another 6, a 7, 5, 5, 5, another 5, 4, 2, 3, 3, 7, 8, 3, 3, 4, 4, 3, 5, and a 2. All right. Now, if I were trying to do the average of this particular set, I could see here that I have 2 2s. And if I were adding all that up, I'd do 2 plus 2 would give me 4. And then I have 5 3s. So 3 plus 3 plus 3 plus 3 plus 3 would be 15. 3 4s would be 12. 5 5s is 25. 2 6s is 12. 2 7s is 14. And 1 8 is 8. And if I were to add all those up, that would give me the sum of all the data points. Now I'm going to use a symbol to write that. We're going to use a sigma. That's a Greek letter. And in math, it means take all the data points and add them up. So if I do that, take all the data points and add them up. 4 and 15 is 19, plus 12 is 31, plus 25 is 56, 68, 78, 82. It gives me a total of 90. So if I'm going to do my average value, then I would need to do the sum of all the data points divided by the number of data points, which would give me 90 divided by 20 for a grand total of 4.5. All right, lovely. So the next thing we're going to do up here is we're going to talk about how well this average actually fits the data set. So an average of 4.5 would sit somewhere around here in that table, so that's not unreasonable. But what I need to do for standard deviation is to decide how far each data point is from that average. So if this was the data points, and this was the number of times they showed up, then this here would be the number of times they showed up multiplied by the value of the data point. The next column I'm going to add is how far away each data point is from that average. So I'm going to jot that in there. Take the data point and subtract the average value. So if you have a 2 is 2.5 below this average. So if I take 2, subtract 4.5, I get negative 2.5. See, my brain had to work there. It's been a long day. If I take a 3, 3 minus 4.5 is minus 1.5. 4 minus 4.5 is negative 0.5. 5 minus 4.5 is plus 0.5. 6 minus 4.5 is 1.5. 7 minus 4.5 is 2.5. And 8 minus 4.5 is 3.5. Lovely. So that's how far each particular data point is away from this average value. Now, in the formula, you're going to have to do that for each data point and then square it and then add up all of those values. So I need to take this and I need to square it so that I lose this positive or negative attached to it. So 2.5 squared would be 6.25. 1.5 squared is 2.25. 0.5 squared is 0.25. 0.5, so I've got the same number here. 1.5 would be 2.25. 2.5 is 6.25, and I have left my calculator elsewhere, so 5 times 35, 5 times 5 would be 25, 17, 15, 12.25. Now, I'm going to go and I'm going to check that because it would be really embarrassing to continue if I didn't have that number. So I did it. It's the right number. 3.5 squared is 12.25. Now, I am going to run out of room here because my face is in the way, but when you go through this, so that was, what was that? That was the data point minus the average squared. Now, in order to get your standard deviation, I needed to have the sum of these things averaged up over the number of numbers. So this 6.25, what you were doing manually was taking 2 minus the average, square it, put it in the list. Take the next 2, subtract the average, square it, add it to the list. So if I did that twice, 6.25 from the first one plus 6.25 from the second one would end up giving me 12.5. And so basically I just took the number of times it showed up and multiplied it by this particular value. So if I had 5 of these, I would have 2 times 5 is 10, and 5 times 0.25 is 1.25 for 11.25. And then 3 of these times that, 3 times 0.25 would be 0.75. 5 times 0.25 is 1.25. 2 times 2.25 would be 4.5. 2 times 6.25 would be 12.5. And 1 times 12.25 is just 12.25. So you can see this around my face there. I'm going to take all these numbers and I'm going to add them all up so that I can get the sum of x minus x bar squared. So give me a minute while I grab the calculator. It's 12.5 plus 0.75 plus 1.25 plus 4.5 plus 12.5 plus 12.25 gives me a total of 55 here. I'm just going to check that. That's a half. So 0.75, 1.5, 1.75, 2.25. 2.5 would be 3, 15, 26, 27, 31, 43, 55. Perfect. So I have this number here. Now I'm going to erase this giant mess so that I have just these numbers, so we can actually do the standard deviation calculation. So there was a formula in the notes for how to calculate standard deviation once you have these numbers. So sigma x, that standard deviation, is the square root of the sum of all the data points minus the average, then squared, divided by n. So I have this number here. I know n is 20, so I just have to fill them in. Sigma x is the square root of 55 divided by 20. 55 divided by 20 is 2.75. And the square root of 2.75 is 1.658. So great, you have a number here, 1.658. So what does that do for you? Well, keep in mind that this particular data set was the amount of time it takes someone at a restaurant to make your food for you, and we came up with an average time of 4.5 minutes. Now, some of those, if you look at the data set, are a lot bigger than 4.5 minutes, and some of them are a lot less. So if I were to quote you 4.5 minutes as the average, that's not enough. I need a window around that value to decide what a long preparation time would be and what a short preparation time would be. And that's what this is for. What we've got here is enough information to come up with a typical value, typical. So on the high end, we're going to take this standard deviation and we're going to add it to the average. So that would be 4.5 plus 1.658. And I get 6.158. Then, if I want to do on the low end, instead of adding the standard deviation, I'm going to take it away. And so that would be 4.5 minus 1.658, which gives me 2.842. So you've just calculated, based on a sample of this person's behavior while making sandwiches, that they take typically between 2.8 minutes and 6.158 minutes. Let's just, for ease of language, call it 3 and 6. So when you set this person to making someone's lunch for them, they get their order, they start to make the sandwich, and it takes them between 3 and 6 minutes to do it. Now, if you're trying to run a restaurant and you are trying to staff it at lunch, and you can tell that typically it takes them a maximum of 6 minutes to make a sandwich, typically, then you can figure out that they can only make 10 sandwiches in an hour, and expecting them to do more than that would just create a lineup. So if you've done more data research there and you figured out that you sell 50 sandwiches in an hour at lunch, and this person can only make 10, then you need to hire 4 more staff. And it's justified based on the demand that you're going to have and the time it takes them to make a sandwich. So there are people who are paid enormous sums of money to come up with these numbers and to help justify expenses and hiring practices and trying to judge whether someone is an effective and quick and efficient employee or not. And if you want to be one of those people, you can go and get a degree in actuarial science, and you will start out of university, and I'm not making this up, with a 6-figure entry salary. Now, it's a bit of a nightmare to get there, but it is something to consider if you're looking for a career in mathematics. So net, what we've done is taken a bunch of numbers, boiled them down to an average to say this is the middle. How long does it take to make a sandwich? About 4.5 minutes. But what's a more important piece of information, or maybe more useful, is that it's 4.5 minutes plus or minus 1.658 minutes. So that a typical sandwich construction time sits somewhere between 2.842 minutes and 6.158.